Welcome back, hyperbolic coding chamber novices. This is June 26th, day 13, 14, 15. I don't know. Late at night, 10:29 p.m. I got the creatine ready. Got 20 minutes on the clock. I can't go too long today since it's pretty late, but minimum required time is 20 minutes, so that's what we're going to get into. Reflections on yesterday. I was doing anything yesterday. I'm probably going to do anything today. My mind is feeling a little bit more clear though. It looks like we have one problem to do. The mic quality isn't going to be absolute dog water. And some random weighted problems to do. We did Excel sheet column number yesterday. We failed on two sum. I looked at the solution. We didn't do majority element or missing ranges though. So honestly, I should do more. I could do 40 minutes today, but when I upload it, it won't make it onto YouTube in time because it takes like an hour to upload an hour-long video. So it has to be like 30 minutes. So that's what I'm gonna do. So yeah, valid parentheses to start, and so I'm just gonna jump into it. Actually today, maybe I'll do a new problem. I don't know. Old problems. Are old problems a waste of time? Am I using my time most effectively? Unlikely. Actually, all right, I've returned. I'm thinking we're gonna start with validate parentheses, and then I'm just gonna go into 2 sum 3, which dunked on me yesterday. So this is going to be the timer. Everything looks good, so I'm just gonna jump into it. So valid parentheses, our goal is linear time with linear space. Just gonna jump into the problem. So a function is valid, and we're passing in a string, and we're returning a Boolean. So given a string S containing just the characters opening, paren, closing, paren, open curly, close curly, left bracket, right bracket, determine if the input string is valid. Input string is valid if open brackets must be closed by the same type of bracket. Sounds a lot like programming. Open brackets must be closed in the correct order. It's very simple, similar to programming. So we have S equals 2 parentheses, sort of like a function call. It's valid because it meets both rules. It's both closed by the same type of brackets, 2 parentheses, and open brackets must be closed in the correct order, and they're closed in the correct order. So you have another one here. They all match, and they're all closing in the correct order. In this one, we have a returning false, and we're actually breaking both rules. How are we breaking both rules? Well, they're not matching. They're not being closed in the correct order. So it's interesting because these two rules are actually similar in the sense that it's being closed in the correct order, right? But it's not actually matching the same type of brackets, right? But it's kind of confusing because if you're not being closed, so the problem writers know what they're talking about. So how do you go about doing this? So we basically need a method of checking that these two parentheses, like as we go through, that everything matches what it says it matches, right? But you can also have sub expressions which aren't as simple as these, right? You could have something like this, right? Where what you're checking isn't just checking 2 characters at a time, right? It doesn't say that we're always going to get them paired together correctly like this. So if you get something like this, in which case it's actually not valid, right? Because we have 5 left parentheses and 4 right parentheses, right? So if we match them all together, we end up with 1 open parenthesis. So that's definitely not going to work, right? So what we really need is a method of being able to make sure that the last time, the most recent bracket we see is the one that should be processed most recently. So if we're looking for something that where the last thing we've done is processed the soonest, what we're looking for is a stack, right? So we want to process the most recent parenthesis to see if it's being closed correctly, right? that would be this left parenthesis right here in the middle. We want to process that one first, not this left one first, right? So the reason we'd use a stack is because for every open parenthesis, we can push that onto the stack, right? And the stack is going to allow us to keep a running order of the correct order that these parentheses should, or these symbols should be closed in, right? And so that's really going to be the basis of how this problem is solved. And I never clicked start time. I'm going to start the time right now. I'm gonna do it like this just so I can see it. Okay, so you can just jump into it, right? So we're gonna need a stack, and the stack that we're just gonna use an array that we're just gonna only operate at the end of, which is basically the same, because pop and push are gonna operate in constant time, sort of, because the stack was using an array and it's going to be dynamic in JavaScript. If we push onto the stack, we have to create more space. So it's not that simple, but it's close enough for this. So we're going to have a stack, right? We're also going to need some sort of table, right, to map matches to. So how do we know a left parenthesis matches a right parenthesis, right? And so what we're looking for is actually something perfect, which is a map. And you can actually construct a map from a list of tuples. So we'll say this one matches this one, right? And then we're going to duplicate this line and do it 2 more times. We're going to say that a left curly matches a right curly, and a right bracket matches a left bracket. And you should be able to construct a map from this. And so we should be good there. So we'll have a way, right? So now we can say, hey, you know, map dot get, you know, left bracket. What are we going to get back from the map? It's going to be a right bracket, right? So we have a way to get what we need. All right, so how do we solve this problem? So we're going to iterate over S, right? And for every character that we add, for every character in S, right, there's only a couple of cases, right? Either the character is an opening bracket, right? It's an opening symbol, so left, curly, paren, or bracket, right? Or it's a closing curly, paren, or bracket. So we need a way to separate these, right? So the stack, like we said, is going to be used to only handle the opening braces because we want to make sure they're being closed in the correct order. So the only thing that will ever exist in the stack is opening symbols. So we're going to say if map.hasChar, right? So if the map has the character, then it must be a closing character. It must be an opening bracket, right? So we can say stack.pushChar, right? And we're going to say else if, okay? So if the first statement is if it has a character, right? Then our else if, right, is going to be if the first statement is if it is an opening symbol, then our else if is going to be if it's a closing symbol. So if we have an opening symbol, we're going to push it onto the stack, right? Push it onto the stack, push it onto the stack. Now, if it's a closing symbol, what do we want to do? If it's a closing symbol, we want to check. We're going to check if the stack isn't empty, right? And if we check the last element, right, in the stack, the most recently added opening symbol, right? Because the stack only holds opening symbols. If we check the most recently added, which would be stack substack.length -1, right? Opening symbol, right? The most recent opening symbol of the stack, and we pipe it back into the map, we're going to get the closing symbol for that opening symbol. Now, if it matches character, then we have is a perfect close, right? We have a bracket being closed by its match, right? And if that happens, what we want to do is we want to pop that bracket from the stack because it's a good thing it found its buddy. We want to remove it so we can continue to find buddies for the other one and make sure that it matches these 2 rules that we mentioned earlier, right? And so if it's an opening, right, we're going to push on the stack. If it's a closing and it matches the most recent opening symbol on the stack, then we're going to remove it. That's great, right? So if it doesn't pass either of these 2 rules, then it must be a closing bracket, right, that doesn't match the top of the stack. And in that case, we just want to return false because the string isn't valid, right? So we can run this in our head really quick with gamed input like s equals left paren and right bracket, right? So our map is going to have all the matches in it, right? And our stack is going to be empty, right? So we're going to go through and iterate over every character in S, right? Does the map have the character, the first character, which is left paren? Well, it does, which means it's an opening character. So we're going to push, right, left paren onto the stack. All right, we're going to go to the next iteration. So does the map have right bracket? It doesn't, right? Okay, let's go to our next case. Is the stack empty? It's not, so that's good. Let's get, right, stack.stack.length -1. So stack has one element in it, -1, it's going to be 0. So the 0th element in the stack is going to be this left parenthesis here. Well, for this left parenthesis, let's pipe it back into the map and get its matching symbol, which is a right parenthesis. Okay, so now we've got a right parenthesis. This whole line right here, subsection of the line, translates to right parenthesis. Now, does right parenthesis equal car? Well, car is currently this right bracket, right? And they're not the same, right? So we're going to go to this else statement and return false. This string is not valid. Now, if we change our output, right, to this left paren, right paren, we can see that this line, instead of going through case to line 19, it goes through line 17. We end up popping it from the stack, and we're good. We end up being able to return true, right? And so all is well, right? Seems good, right? But if we slow down, let's say we have a different input. We have 2 left parentheses and 1 right parenthesis, right? Our output code essentially runs the same, right? Because we stopped once we popped that last opening character off the stack. So let's pop it, and then what we return true, right? But wait, when we stop, we realize that if we return true here, the string actually wasn't valid because there's still an element remaining in the stack, right? So actually did a bad job explaining. This is the stack, not the string below it. So this is the string that we passed in. So we actually popped this left parenthesis off the stack. There's still 1 parenthesis left in the stack. And so we can't just return true. We have to return if the stack is empty. So if the stack is empty after checking for all matching pairs, then that's great because it means we found all the matching pairs. But if the stack isn't empty, it means we didn't find all the matching pairs, which is no good. And so that looks good. And it looks like this is going to run in linear time with linear space in the worst case because of this stack we're using. The worst case string that could be entered is actually like this. We'd have like 35, or let's just say up to n opening brackets in the stack, just to never run this line, just to run this for loop, right, where we would just basically be pushing all the opening symbols onto the stack, right? Never running any of the actual other cases, just to check that, right, the 9,000 left parentheses in the stack, right, doesn't equal 0, and that's the worst case, right? That it's just a bunch of open brackets, or it's just a bunch of left opening symbols. So that looks good. Loop pass. And I said we'd try 2 sum 3 again, so we can do that. This was the solution I was working on before. It's all over the place. The intuition behind this problem is that they have a data structure, right, which supports 2 operations, add and find. Add adds a number to the data structure, right, and find returns true if there exists any pair of numbers whose sum is equal to value. Otherwise, it returns false, right? So we're trying to create a data structure such that when we run this find operation, we can figure out, hey, if we try to find 7, are there any 2 numbers in our internal array that sum up to 7? And we're trying to do it in a respectable amount of time. You can currently do this in n squared time just by adding all the numbers into the array and just doing a double for loop over them and checking every possible combination with every possible combination until we find a number that sums up to the value we're searching for. What I was going for here, I think, is that I tried to use a map where what we would do is every time we'd add a number to the array, right, we'd also, right, keep a running map. And the map would, once we added a number, right, we would iterate through all the numbers in the array and add them to the map, right? And so when we run find, we could just get the value from the map to know if there are any two numbers that sum up to that number, right? And that doesn't make any sense right now that I'm thinking about it. I think I was just low on sleep, because if every time we add a number we have to iterate through the array and add all the sums of that current number with all the numbers in the array, that's like n times n operation. That's even worse than n squared. So it was even just an awful idea to try. I think we can do better with n log n by doing something differently. I don't think you need this constructor, so I think you can just say, can you do r equals like that? Maybe you can't in vanilla JavaScript, but this is TypeScript. It actually doesn't matter because TypeScript annotations get stripped from the file. So can you do this? I don't know. Let's just run with it. So the way we can do it actually is by doing sorting, right? And this version would actually run n log n time at the worst case, but linear time in the average case. And how could we do that? Well, the intuition here is that every time we have a number added to the array, we'll just go ahead and this dot push add, right, to the this dot array dot push the number, right? We're just going to add that number to the array, and I'm going to make this slightly bigger, right? So that makes sense, right? But how do we find the number? Well, the way we find the number is by keeping a sorted tag, right? So we'll have a variable, right, is sorted, and it's going to equal false, right? And so how does this work? Well, it works like this, right? If the array, if is sorted, if it is not sorted, right, what we're going to do is just sort the array. So we were going to do r dot sort. It's going to sort it in place a b, right? And we're going to do b minus or a minus b to sort it in ascending order, right? Because it's just an array of numbers. And then from here, right, we're going to say, hey, is sorted now equals true, right? We sorted it. So we can just say this dot sorted is true, right? And when we push a number onto the array, we're going to say this dot is sorted is now equal to false, right? And so this one is going to be optimized for loading a bunch of numbers into the array. And then you can find, if you call find 8 or 9 times, you can always find the answer to your question in linear time. But in the worst case, we have to sort the array ahead of time, which is going to take n log n time. So in this case, what you can do here is just do for I equals 0, I is less than this dot r dot length minus 1, since we're going to be checking elements in terms of pairs, right? We don't want to run into the last element into the array, because we're going to say, hey, if r sub I plus r sub I plus 1 equals value, right, then return true. Otherwise, if we make it all the way out here and we never found two numbers that match, we're going to return false, right? And since we're checking I and I plus 1 at each iteration, the end of our array has to stop 1 before the end, since at the length of the array minus 1, we're going to check that last element inclusively. Right, so we can return false here. And I feel pretty good about this. So I think we should be able to run this I said is sorted. I should have said dot. This dot is sorted. Let me make sure I didn't miss anything out. This dot is sorted. This dot r dot push number. I'm also not certain how you can do number here and number here because I thought number was a keyword. Or the type. Oh, I guess it's a type in TypeScript. You probably can't use it in TypeScript, but you can use it in regular JavaScript. Iterating over, we're going to check, hey, do all the two numbers in the array, we need them to sum up to value. The reason this works is because since they're sorted, wait a second. Wait a second. Even if you sort the array, it doesn't actually help you find if there are two numbers that add up to the number you're looking for. I guess you could also add a if you added a set, right, you could say this dot set dot add the number, and the sorted helps you with the first part because now you can actually iterate, and we're going to subtract the -1, and we're not going to check both values. What we're going to check is if we do, let's call this variable the golden value, we do the math.absolute value of value minus nums, or this dot r sub I, right? So I'm gonna make one just to fix that spacing issue. So when they try and find 7, right, our set is gonna store 1, 3, 5, and 4. Oh no, these are two finds, 4 and 7. Our set's gonna store 1, 3, and 5. Right, and once we sort it, it doesn't matter in this case because it's gonna be 1, 3, and 5. But the sorting helps because we can check in order, right? So when we want to find if there are two numbers that sum up to 4, if we want to find there are two numbers that sum up to 4, all we have to do is check if the value, right, which is 4 minus 1, which is 3, right, it's going to be the golden value. All you have to do is check if 3 exists in the set. And so what we can do is say if set.has golden value, right, then we can return true, right? So we're basically checking the difference here, right? And we're checking if this magical difference number exists in the set. And if it does, then we know that there are two numbers such that if they're added, they would equal 4. So if we run this for 7, we're going to iterate, right, over 1, 3, and 5. We're going to do 7 minus 1, right? We're going to get 6. Does 6 exist in the set? It does not. Okay, 7 minus 3 equals 4. Does 4 exist in the set? It does not. Okay, we're looking for 7, right? We're going to do 5 minus 7. The absolute value of that is the difference between the two numbers. It's going to be 2. Does 2 exist anywhere in the set? It does not. And so I'm feeling good about this one. I did r dot sort this dot r. This is getting me. I'm so used to linting programs just telling me when my code is not following the correct ideas. Okay, so we don't pass a case when we add 0 to the array, and then we try to find 0. Well, 0 is in the set and it's in the array. We're going to iterate over the array. If we do 0 minus 0 was golden value, does the set have the golden value? Well, 0 should exist. Output is true. Oh, our output is true. I see, our output is true, but it should actually return false. This is the same problem the other algorithm had. It had a problem with zeros. It's always good to check 0 if two numbers can be summed up. In this case, two numbers cannot be summed up. Yeah, this one, I think I've been bested on this one. I think the actual solution, I figured it out. I think the actual solution is that this is a two-sum data structure. So it's how can you optimize this problem for two-sum? And how can you optimize this data structure for two-sum? There's already a two-sum algorithm, I think that's DP-wise, that you can check, right, in linear time. And I think that's what you're supposed to run here instead. But I'm trying to do it with maps and sets, but it's a little messy. So how would you just write two-sum if you had the array of numbers and they were sorted? How would you check if you had an array such as 1, 3, 5, right? How would you check if there exist two numbers such that it equals 4? I think you could do what I was going to do earlier, right? You could do it pairwise, add them, right? But not exactly, because 1 and it's strange because it ends up feeling like it's n squared time anyway. You can do this with n squared time, even if it's not sorted. So I think I just actually don't know how to solve the core problem, which is how to find two numbers that sum up to a number in a speed that's not n squared. But I'll write the n squared version for the sake of writing it. So we have 4 let I equals 0, I is less than the array dot length. And then what we would do is just duplicate this part, push this part forward, and what we would do is we would say if, we'll call the second variable j plus plus, right? And we want to skip the index that we're on, right? So if j does not equal k, and this dot r sub j plus this dot r sub k equals value, and we'll return true. The reason we have to skip the indexes, right, if they're the same, is because we don't want to make sure, we want to make sure, I'm saying k, it's I. We have to make sure that there exist two distinct versions. It is, yeah, two distinct versions of a number exists. If we don't skip the indexes, right, if we get to 0 again, we'll return true, but it's because we're at the same index for both. We'll be at the same index. So this should match up with this if statement. This is the first 4, this is the second 4. After it, this actually doesn't even need to be sorted. But it might just say run out of time because an n squared solution is not the goal here. But I might just have to read the solution for this one. Problems of the first problem on LeetCode called two-sum, right, where one is asked to return the indices of two numbers from a list that could sum up to a given value. It could be numbers in the list. So one of the solutions to the two-sum problem is a two-pointer iteration. Interesting. But the prerequisite for that solution is that the input list be sorted. So we were on to something with it already being sorted. Should we keep the list in order while inserting new orders? Sure, should we do sorting on demand? Loop to iterate the list, loop will terminate either when we find some. This point they're talking about here sounds like a binary search. But let's peep the code. Let me zoom out just a little bit. Is sorted, right? If we add a number to the array, right, then is sorted equals false, right? Starts at false. We add a number to the internal data structure, then we set it to false. All right, and if it's not sorted, then we sort it, change it to true. That's what we did. Looks like they're doing a binary search. Because any pair of numbers which sum is equal to the value. I'm not seeing how a binary search solves the two-sum problem. This.nums.get low. Oh, I see. I think I see what they're doing. So they're saying while low is less than high, then if we sum up the low and the, so they're using the binaries, they're not actually calculating the pivot. They're using a different method of slicing the search. Oh no. I see. So if two-sum is less than the value, then they move low up, and if two-sum is greater than the value, then they move high down. In this way, you're kind of sliding them both up and down until you meet the value. Right, because it already has to be sorted. That's interesting. That's a really cool solution. I think the next time we try this problem, we should be able to figure this one out. But it's with the indices, low and high are the indices, and you actually still have to get the number. I see. So I got dunked on by this problem, but I'm gonna wrap it up there. That's day 13 or 14.